সুপ্রিয় শিক্ষার্থীবৃন্দ, আমরা আজকে 10.3 অর্থাৎ দশম অধ্যায়ের তৃতীয় যে বিষয়টা, সেখানে ফর্মুলা অফ ইএমএফ ইকুয়েশন অর্থাৎ ইএমএফ ইকুয়েশন এর যে ফর্মুলাটি E=-n ডেল্টা ফাইম বাই ডেল্টা টি ইকুয়েশনটি প্রতিপাদন করব। এখানে n নাম্বার অফ লুপস, delta phi is equal to change in magnetic flux, delta T change in time, or induced voltage. Induced EMF in a coil, EMF is equal to minus n delta phi by delta T, n phi on minus phi 2 by delta T. Maybe এখানে number of turns in the coil, A area of the coil, meter square delay, magnetic field, phi magnetic flux in Tesla meter square, delta T time is takes from the এখানে আমরা একটা উদাহরণ দিয়েছি is equal to d5 by dt। এখান থেকে আমরা যেটি পাবো যে এর মান delta v by delta t। Lenz's law states that the current induced in a circuit due to a change in a magnetic field is directed to opposite the change in flux and to exert a mechanical force which opposes the motion. Lenz's law is an important concept in electromagnetism. It states that when a voltage is created by a change in magnetic flux, the induced voltage must create a current whose magnetic field is in opposition to the change which produces it. Because like magnetic poles repel each other, Lenz's law states that when the north pole of the bar magnet is approaching the coil, the induced current flows in such a way as to make the side of the coil nearest the pole of the bar magnet itself a north pole to oppose the approaching bar magnet. Fleming's right-hand rule shows the direction of induced current when a conductor attached to a circuit moves in a magnetic field. It can be used to determine the direction of current in generator's winding. Self-induced EMF, self-inductance. The induced EMF in a coil is proportional to the rate of the change of the magnetic flux opposing through it due to its own current. This EMF is termed as self-induced EMF. The induced EMF is proportional to the rate of change of current through coil, and this proportionality constant is called the self-inductance. E1 is equal to minus L d phi by dt. The negative sign is used to indicate that EMF is opposing the force producing it. Flux line, induced EMF, current, switch, battery, self-inductance. How we induce self-inductance? Iron core inductor. The iron core inductors have a very low value of inductance in the iron core inductor. By using iron core, the inductance value of an inductor can be increased. The iron core inductor is the fixed value inductors which have iron core and iron core placed inside inductor coil. In real transformer, the two coils are wound into the same iron core. The purpose of the iron core is to channel the magnetic flux generated by the current flowing through primary coil, so that as much of it as possible also links the secondary coil. Iron core inductors large inductance values but have large power losses at high frequencies. For high frequency applications, particle core inductors are used. Definition of mutual inductance and coefficient of coupling. Mutual inductance between the two coils is defined as the property of the coil due to which it opposes the change of current in other coil, or you can say in the neighboring coil. When the current in the neighboring coil changes, the flux sets up in the coil, and because of this changing flux, EMF is induced in the coil called mutually induced EMF, and the phenomenon is known as mutual inductance. Coefficient of coupling. The fraction of magnetic flux produced by the current on one coil that links with the other coil is called the coefficient of coupling between the two coils, where K is equal to when the flux produced by one coil completely links with the other coil and is called magnetically tightly coupled. Mutual flux N2 K phi on L1 into N M square is equal to K N phi on ion into N2 phi 2 will be equal to K square L1 L2 M is equal to L1 L2 root over. তো আজকে আমাদের আলোচনা এই পর্যন্ত করলাম। এখানে তোমাদের কোনো প্রশ্ন থাকলে প্রশ্ন করতে পারো, পরবর্তীতে আমরা আবার অন্য আলোচনায় চলে যাব। তো এই পর্যন্তই এই ক্লাসটি শেষ করছে, পরবর্তীতে আমরা অন্য আলোচনায় চলে আসবো।